Determine the left-sided limit and the right-sided limit and the two-sided limit as x approaches pi of -1 over cosine squared x plus 2 cosine x plus 1. Each of these involves the limit as x approaches pi of -1 divided by cosine squared x plus 2 cosine x plus 1. The first thing to do is try plugging a pi in for each of the x's. That'll give a -1 divided by cosine squared of pi, which means the cosine of pi and then squared, plus 2 times the cosine of pi and then plus 1, which equals -1 divided by the cosine of pi is a -1 and then squared, plus 2 times cosine of pi is a -1 and then plus 1. Which equals -1 divided by -1 squared is a +1. 2 times a -1 is a -2, and then plus 1. Which gives -1 over 1 minus 2 is a -1 plus 1 is a 0. That 0 in the denominator is not actually a 0 since x is only approaching a pi here. It does not reach pi. But a limit result of a non-zero number over 0 equals to either positive infinity or negative infinity, where the sign of the infinity often depends on the side the limit is approaching from. Therefore, we have to work out each of the one-sided limits separately. We have the left-sided limit indicated by the negative superscript on the pi. Of -1 over cos squared x plus 2 cos x plus 1. And the right-side limit indicated by the positive superscript on the pi. -1 over cos squared x plus 2 cos x plus 1. Let's start with the left-sided limit. The denominator is a trinomial quadratic and can therefore be factored because it has a cos squared term, a cosine term, and a constant, making it a trinomial quadratic. It can factor into a cosine of x and another cosine of x. We need two numbers that multiply to be +1 and add to be +2. +1 and +1 will take care of that. Since they match each other, they can be combined as a quantity squared, giving -1 over cosine of x plus 1 squared. Now we can analyze what's making 0 in the denominator a little better here. X approaching pi, and cosine of pi is a -1, and -1 plus 1 is making 0 in the denominator. X is approaching pi from the left side here. Left side of pi means less than pi, but close to pi. Less than pi in the unit circle, we'll put it in the second quadrant. Cosine of pi is a -1. Cosine of something less than pi is less negative than -1 because it can never be more negative than -1. Cosine never goes more negative than -1. So it'll be less negative, like -0.99. If that's plugged in for the cosine of x and added to 1, that is a positive number. But it's going to have x approaching pi and cosine of x approaching -1, and -1 plus 1 is 0. So it's going to approach to 0, but it's going to stay positive. Therefore, cosine of x plus 1 can be replaced with a +0. A pi can be plugged in for all other x's. There is no other x's. So it will give us -1 over a +0 squared, which is a -1 over positive squared is positive, 0 squared is 0. A negative over positive is a negative, non-zero over 0 is an infinity. And there's the result of the left-sided limit. The right-sided limit will work out in a similar fashion. It will go through the exact factoring process, trinomial quadratic, and it factors into cosine of x plus 1 times another cosine of x plus 1. Therefore, quantity squared in the denominator. Now we can analyze it according to the side. It's approaching from the right side of pi, which is greater than pi, but near pi. On the unit circle, greater than pi is in the third quadrant. Cosine of pi is a -1. Cosine of something greater than pi, but near pi, will be less negative than -1 because it can never be more negative than -1 for cosine. It's less negative, like negative 0.99. If that's put in for cosine and add to 1, that's a positive number. It's approaching to a -1. -1 plus 1 is 0, so it's approaching to 0, but it's a positive number the entire time. Therefore, we can replace cosine of x plus 1 with a positive 0. We can plug in pi for all remaining x's. There is no other x's, so the result is -1 over positive 0 squared, which is a -1 over positive squared is positive, 0 squared is 0, negative over positive is negative, non-zero over 0 is infinity, and there is the result of the right-sided limit. The two-sided limit depends on the results of the one-sided limits. They match each other here, negative infinity, so the two-sided limit up here will be that same result, negative infinity, and there is the results of the three different limits.